Okay, now we're going to look at an application of quadratic equations, and that is the position function. And you'll have different ways that this position function is going to be. The problem says an object is propelled upward. Its height in feet is given by the function f of t, which is equal to times t is its height 70 feet, round to the nearest tenth of a second. Notice that with these position functions, that if you give t a certain value, for example, if you let 1, then f of 1 evaluating this position function, and this is a function, right? Letting t equals 1, evaluating f of 1 would mean plus 80 times 1 plus 50 is the position of the object at t equals 1, and in this case we're talking about seconds. So what is the position after 1 second? 1, and so we get minus 16 plus 80 plus 50 plus 130, and that's the same thing as 114 feet. So after 1 second, round. Its height is 114 feet. Okay? Now, in this case, the particular problem asks us, at what times t is the height 70 feet? Well, notice that when t equals 1, the height is 104. Did here, we calculated the y value when t was equal to 1. So if we have the height being 70 feet, that means that the y value is 70. For this particular problem, what we're going to be needing to do is to find what t equals in order to give us a height of 70. So for the problem, 70 feet means okay. Remember that with functions, the y is the value of the function. So what we need to do then is set this equation equal to 70. So we will have 70 equals a negative 16t squared plus 80t plus 50. Well, this is nothing more than solving a quadratic equation. We've learned to solve quadratic equations. We'll have one side equal to 0, a negative 16t squared plus 80t, adding a negative 70 to both sides, we get a negative 20 on one side. Problem a little bit easier by noticing that there's a 4 factor in each of these 3 terms. So let's factor 4 to the outside, and we'll have a negative 4t squared plus 20t minus 5. Now, notice that when we're solving quadratic equations, we have 0 on one side, and we're able to factor a constant factor to the outside. We could just as well divide both sides of the equation by 4, and so when we do that, on the right-hand side, we'd have negative 4t squared plus 20t minus 5. On the left, we would have 0 divided by 4, but that's just 0. So we've made the equation a little bit simpler by having smaller numbers to work with. Factors don't jump at me from here right away, and so I'll go ahead and solve this particular equation. Remember that the values for t are going to be plus or minus the square root of b squared minus 4ac divided by 2 times a. So in this case, we're solving for t. The a value quadratic formula, so we have t equals minus b. In this case, b is 20, so that would be a plain minus 20, plus or minus the square root of b squared minus 4 times, and this is all divided by 2 times a which is that 2 times negative 4. All right, so now simplifying this, we're going to have minus 20 plus or minus the square root times a minus, that will give us a negative. 4 times 4 is 16, 16 times 5 is 80, so we have 400 minus 80 divided by a negative 8. And so solving for t, continuing to solve, we have t equals a negative 20 plus or minus the square root of 320 divided by a negative 8. Let's simplify that 320 a little bit. We know that 2, and so we could factor the 16 to the outside. 320 is going to be 16 times 20. I guess we could simplify a little bit more. So let's work a little bit on the side here. 320 is the same thing as 32 times 10, but 32 is the same thing as 2 times 16, and 10 is the same thing as 2 times 5. So we actually have a perfect square 4 and a perfect square 16 inside the radical. So we can the 4 goes to the outside as a 2. Inside the radical, we're left with 5, divided by a negative 8. Okay? Work with this, and notice that we're going to have t, which is equal to a minus 20 plus 8 times the square root of 5 equals a negative 20 minus divided by a negative 8. Notice that for the numerator, we're going to have a positive value because, I'm sorry, for the t in the second, end up with a positive value. And when you figure out these two values for t, you will have that one of them, and you can use your calculator for that, one of them is 4.7 seconds, and the other one is t approximately 0.26 seconds. Those are legitimate answers. It turns out that for these two values of t right here, we're going to have a height which is 70 feet. When you're looking at your calculator and putting the square root of 5 in your calculator, what the calculator gives you is an approximate value, and that's what these two little wiggly lines, approximately 4.7 seconds. We have to round that off. And the same thing for this one. T is approximately 0.26 seconds. So if you remember, going back to the problem, we had the position going to be 70 feet high. It's going to be when t is approximately 4.7 seconds or t approximately 0.26 seconds. Two different values. Turned out to be negative, then you'd have to throw that out because t is time. But in this case, we have two possibilities, and they both are fine possibilities.